When encountering situations where a homeowner has performed electrical work and requests connection to the panel, several factors must be considered, primarily focusing on safety, code compliance, and professional responsibility. Firstly, electrical code compliance is paramount. Verify if the newly installed circuits meet electrical code requirements. Secondly, ensure there are no electrical hazards or unsafe conditions present. This includes checking for proper wiring methods, secure connections, appropriate overcurrent protection, and correct grounding and bonding. From a professional ethics standpoint, accountability is crucial. You assume responsibility for the safety and functionality of the electrical system, including any work you performed or connected to. It is important to adhere to industry best practices and ethical guidelines. When handling such situations, it is recommended to follow a structured approach. 1. Request documentation. Ask for proof of permits, inspections, and any relevant documents. If they cannot provide documentation, proceed with caution. 2. Conduct a thorough inspection of the work to assess its quality and compliance. Bring necessary tools and equipment for testing and verification. This includes a multimeter, voltage tester, and clamp meter. 3. Clear and open communication with the homeowner is essential. Explain your safety concerns and professional responsibilities. Offer to complete the installation if the new circuits meet code requirements and are safe. If the work is not up to code or safely installed, inform the homeowner and provide recommendations for addressing the issues. 4. If necessary, arrange for an independent electrical inspector to verify the work before connecting it to the panel. This can provide an impartial assessment and documentation of the installation. 5. Ensure adequate insurance coverage in case of any accidents or damages related to the work. Consider having the homeowner sign a waiver acknowledging that they assume liability for any work performed by others. When communicating with the homeowner, a suitable response could be something like this: "Thank you for calling. I understand you have done some electrical work, but I am not comfortable connecting it to the panel unless I can verify it meets safety standards. I would be happy to come out and inspect the work. If it meets code requirements, I can proceed with the installation. If not, I can recommend qualified electricians who can address the issues." This approach prioritizes safety, code compliance, and professional integrity while addressing the homeowner's needs. When inspecting the wiring, examine the wire size and type to make sure it corresponds to the circuit breaker size and the intended load. The National Electrical Code, or NEC, provides tables for allowable ampacities of conductors. Make sure the connections in the junction boxes are properly made and tightened. Loose connections can cause arcing and overheating. Check the grounding and bonding system to ensure it is properly installed. This includes checking the grounding electrode conductor, the grounding bus in the panel, and the bonding of metal enclosures. Verify the overcurrent protection devices, such as circuit breakers, are of the correct size and type for the circuits they protect. The NEC specifies requirements for overcurrent protection based on the ampacity of the conductors. For example, NEC Table 310.15. V16 provides ampacity ratings for conductors based on their insulation type and temperature rating. When working with electrical panels, always turn off the main breaker to de-energize the panel before working on it. Use the voltage tester to confirm that the panel is de-energized before touching any wires or components. When connecting new circuits to the panel, follow the NEC requirements for wire bending space and fill capacity. Do not overload the panel by adding too many circuits. The total load in the panel should not exceed the panel's rating. When installing new outlets or fixtures, make sure they are properly grounded and bonded. Use the correct wiring methods for the type of installation. For example, use non-metallic sheet cable for dry locations and conduit for wet locations or where physical protection is required. When installing recessed lighting fixtures, make sure they are IC rated if they will be in contact with insulation. This prevents overheating and fire hazards. When working with electrical systems, always wear appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. Follow lockout-tagout procedures to prevent accidental energization of the circuit while you are working on it. Keep a fire extinguisher nearby in case of a fire. If you are not comfortable working on electrical systems, hire a qualified electrician to do the work. They have the knowledge, skills, and experience to do the job safely and correctly. When inspecting a homeowner's electrical work, pay close attention to the details. Look for any signs of poor workmanship or unsafe conditions. If you find any problems, document them and explain them to the homeowner. Offer to correct the problems or recommend a qualified electrician who can do so. Remember, your primary responsibility is to ensure the safety of the electrical system and protect the homeowner from electrical hazard. In residential electrical systems, common wiring configurations include 120 volts and 240 volt circuits. 120 volt circuits are typically used for lighting, receptacles, and small appliances. 240 volt circuits are typically used for large appliances such as electric ranges, dryers, and water heaters. The NEC specifies the requirements for wiring these circuits, including the wire size, overcurrent protection, and grounding. When working with 120 volt circuits, the NEC requires the use of a 15 amps or 20 amp circuit breaker for general lighting and receptacle circuits. The wire size must be at least 14 American wire gauge for 15 amp circuits and 12 American wire gauge for 20 amp circuits. When working with 240 volt circuits, the NEC requires the use of a double pole circuit breaker. The size of the circuit breaker and the wire size will depend on the load. For example, an electric range may require a 40 amps or 50 amp circuit breaker and 8 American wire gauge or 6 American wire gauge wire. When installing new circuits, it is important to calculate the load to make sure the circuit is not overloaded. The NEC provides guidelines for calculating the load based on the type of appliance or equipment being connected to the circuit. When working with electrical systems, always follow the NEC requirements. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect the latest technologies and safety practices. It is important to stay up to date on the latest NEC requirements to ensure that your electrical work is safe and compliant. In addition to the NEC, there may be local electrical codes that you must follow. Check with your local building department to find out what the local electrical codes are. When working with electrical systems, always put safety first. Electrical work can be dangerous if it is not done properly. If you are not comfortable working on electrical systems, hire a qualified electrician to do the work. They have the knowledge, skills, and experience to do the job safely and correctly. When inspecting a homeowner's electrical work, be thorough and meticulous. Look for any signs of problems, no matter how small. Document any problems that you find and explain them to the homeowner. Offer to correct the problems or recommend a qualified electrician who can do so. Remember, your primary responsibility is to ensure the safety of the electrical system and protect the homeowner from electrical hazards. When dealing with electrical work performed by homeowners, another crucial aspect is the potential for hidden dangers. Homeowners, lacking professional training, might inadvertently create situations that are not immediately apparent but could lead to serious safety risks. For instance, they might use the incorrect type of wire for a particular application, leading to overheating or fire hazards. They might also fail to properly ground electrical outlets, increasing the risk of electric shock. Furthermore, homeowners may improperly splice wires, creating loose connections that can cause arcing and electrical fires. It is essential to carefully inspect all connections, splices, and wiring methods to ensure they meet code requirements and are safe. Another area of concern is the potential for overloading circuits. Homeowners might add too many outlets or appliances to a single circuit, exceeding its capacity and causing the circuit breaker to trip frequently. This can lead to overheating and potential fire hazards. It is crucial to calculate the load on each circuit to ensure it is within the safe limits. Additionally, homeowners might not properly label circuit breakers, making it difficult to identify which breaker controls which circuit. This can be problematic when troubleshooting electrical issues or performing maintenance. It is important to properly label all circuit breakers to avoid confusion and ensure safety. When inspecting a homeowner's electrical work, pay attention to the details. Look for any signs of shortcuts or compromises that could compromise safety. If you find any problems, document them and explain them to the homeowner in a clear and concise manner. Offer to correct the problems or recommend a qualified electrician who can do so. Remember, your primary responsibility is to ensure the safety of the electrical system and protect the homeowner from electrical hazards. In addition to the technical aspects of electrical work, it is also important to consider the legal and liability implications. As a licensed electrician, you have a professional responsibility to ensure that all electrical work you perform or connect to meets code requirements and is safe. If you connect to electrical work performed by a homeowner that is not up to code or is unsafe, you could be held liable for any damages or injuries that result. Therefore, it is essential to exercise caution and diligence when dealing with homeowner-installed electrical circuits. It is also important to have adequate insurance coverage in case of any accidents or damages related to the work. Consider having the homeowner sign a waiver acknowledging that they assume liability for any work performed by others. This can help protect you from liability in the event of a problem. Before connecting to any homeowner-installed electrical circuits, it is advisable to consult with your insurance provider and legal counsel to ensure that you are adequately protected. They can provide guidance on the legal and liability implications of your work and help you mitigate any potential risks. Remember, your primary responsibility is to protect yourself, your clients, and the public from electrical hazards. By exercising caution, diligence, and professionalism, you can ensure that all electrical work you perform or connect to is safe and compliant. When evaluating electrical work done by a homeowner, understanding common mistakes they often make can help focus your inspection. One frequent error is improper grounding. Grounding is a critical safety measure that provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. Homeowners may neglect to properly ground outlets, appliances, or metal enclosures, increasing the risk of electrical shock. Another common mistake is using the wrong size wire for the circuit. The NEC specifies the minimum wire size for different circuit ampacities. Using undersized wire can cause overheating and fire hazards. Homeowners might also improperly splice wires, creating loose connections that can cause arcing and electrical fires. Proper splicing requires the use of approved connectors and techniques. Overloading circuits is another frequent error. Homeowners may add too many outlets or appliances to a single circuit, exceeding its capacity and causing the circuit breaker to trip frequently. This can lead to overheating and potential fire hazards. Improperly installed or missing junction boxes are also common. Junction boxes are required to enclose and protect wire splices. Homeowners might leave splices exposed or use improper junction boxes, creating a safety hazard. Another area of concern is improper wiring of three-way switches. Three-way switches allow you to control light from two different locations. Homeowners often struggle with the wiring of three-way switches, leading to malfunctions or safety hazards. Finally, homeowners may neglect to install ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms, kitchens, and outdoor locations. GFCIs protect against electrical shock by detecting ground faults and tripping the circuit. When inspecting a homeowner's electrical work, be aware of these common mistakes and pay close attention to these areas. By identifying and correcting these errors, you can ensure the safety of the electrical system and protect the homeowner from electrical hazards. Furthermore, when you are inspecting the electrical connections, ensure to give each wire a tug. The wire should be firmly gripped by the screw terminal or the wire nut. Wires that easily pull free are a fire hazard. Furthermore, be aware of aluminum wiring. Many older homes had aluminum wiring instead of copper wiring, which is used today. Aluminum wiring has different properties and requires special consideration. Aluminum expands and contracts more than copper does with temperature changes, and aluminum wiring connections can become loose over time. Only use connectors that are rated for aluminum wiring when connecting the aluminum wire to other devices or copper wires. Another aspect to be aware of is arc fault circuit interrupters, or size. A size of special circuit breakers that are designed to protect against arc faults, which are a common cause of electrical fires. A size can detect the unique signatures of arc faults and trip the circuit breaker, preventing a fire from starting. The NEC requires a size in many circuits.